Okay, we are about 2 minutes after the hour, so we'll go ahead and start the call here in just one moment. As a reminder for everyone that's just recently joined, we have our chat window and the Q&A feature inside the Zoom call. If you have any questions for our presenter as we go along, please do use the Q&A feature. That way we can queue up all those questions and address them during that portion. If you'd like to share anything with the group, please do so via the chat. We'd love to have a conversation flowing. We'd love to hear about the projects that you're working on, any articles that you've recently published. It's a little bit difficult to do some of the interacting and the networking that we normally do during these meetups in a virtual setting. So being able to really use and leverage that chat feature is a great way to kind of start some of those conversations, share with the community and the group at large, and kind of do the best we can to foster that same environment that we miss from coming together physically in person. Also, if your company is hiring or if you know any companies that are hiring, I think a lot of people are interested in knowing about any open positions that might be available. So feel free to use the chat feature to share any open positions that you'd like to share with the Time Series community. And as I said earlier, thank you all for joining us. I am Michael Ellis, Community Manager here at InfluxData. We're going to go ahead and kick off the call. We had a couple of icebreaker questions. I appreciate everyone letting us know where they're from and their favorite Star Wars movies. This is our second ever virtual Time Series meetup. We're delighted everyone's able to tune in live and join us. As a reminder, this call will be recorded and we'll be uploading it to YouTube later. We're joined today by our special guest presenter, Saiyam Pathak, who is a software engineer at Walmart Labs. He'll be sharing a great talk with us here in a moment. If you have any questions for Saiyam as we go along, do use the Q&A feature. And we're also joined by Caitlin Croft and Chris Turillo, who are joining today as our group of panelists and moderators. So thank you both for taking the time to join. Saiyam is our special guest today. He is an Influx ace. He'll be providing a practical introduction to Time Series. After the presentation, we'll pause for some Q&A. And after our talk portion of the call, we'll share some announcements and job opportunities with the group. As I mentioned earlier, if you have any that you'd like to share, feel free to use the chat feature to go ahead and do that. And then finally, we'll conclude the call with a swag giveaway. We have some really cool goodies to give out, like InfluxData socks, t-shirts, and hoodies. So I encourage everyone to stay on until the end of the call for that portion. Also, just a reminder, I want to thank you all for registering for this Zoom webinar. Just to let you know, your information is not going to be used for any marketing purposes. It's something that Zoom requires for webinars, and we use this list for the purposes of the swag raffle. For any of our raffle winners, we will be reaching out via email. The purpose of that email will just be to gather some shipping information so that we can send your prize to you. And we will not be retaining any of your personal data afterwards for any other reason other than making sure that we can get that awesome swag out to you. And today we're joined by Saiyam Pathak. Saiyam is, as I mentioned a moment ago, a software engineer at Walmart Labs. Additionally, Saiyam is an Influx ace here at InfluxData. So he's an expert in all things time series, and he's no stranger to meetups. He helps organize several tech meetups and community initiatives in his local area. Today, he'll be providing a practical introduction to time series. After the talk, we'll have some time for Q&A. So feel free to post your questions, anything that you'd like to ask Saiyam, and we'll circle around to those after his presentation. Saiyam, are you ready to begin sharing your screen?
Yes, I am.
Great. I'll go ahead and stop now.
Let me know when you're able to see the screen.
Yeah, looks good.
Okay. Just present it. Anyway, I have to come back to the browser and the start itself. So Thank you for the great introduction, Michael, and hello everyone. Thank you for joining. This is the first ever Influx meetup that I'm doing virtually at this scale, kind of a webinar. So what I thought, why the topic is actually, Time Series introduction in a practical way, because I'll be showcasing two demos, and both of these demos can be performed by you right now when I'm demoing them, or when the this meetup ends. At the end, you want to perform those. Anytime you can do that. I have prepared a small gist for that, so I'll be sharing the URL with everyone. It's a public gist. Just copy paste the commands, and you can play around with Influx. So that's why it is in a practical way. We'll be going through some of the introductions, but most of the part will be hands-on, Dockers, Kubernetes, and all that stuff. Next, already Michael has introduced me. A few additional informations. My Twitter handler is Saiyam Pathak. You can reach me out. My DMs are open for any of the queries related to CNCF, CKA, CKAD, Kubernetes, cloud native stuff. And I'm CNCF ambassador as well. And like Michael mentioned, I'm in Flux Ace. I'm the meetup organizer for Docker, Bangalore, CNCF, and Influx at Bangalore, India. And I'm a Kubernetes member as well. So that's about me. And I'll go back to the introduction. So the thing is, why I didn't put the slides for why time series and what is time series database is because there is a very neat introduction to what is time series data and what is time series database on Influx data itself. So I thought, why not leverage that itself. So obviously recommendation is you read the full article. I'll be highlighting only the main stuff so that we just get hold on like what actually we are talking about over here. So starting off with is what is time series data. So time series data is measured via the time. So your major thing in time series data would be the time. So think of it as like you all are there, and in your lives all the events happen. So each day you have some sort of activities that you do, and they are the time series memories that are recorded in your brain. Similarly, you have machines, you have your sensors, you have your applications that emit data on daily basis. Those data at that particular point of time, the thing that they are doing can be stored in a form of time series data. So that particular data will be a time series data, like your application went down on Saturday morning 9 a.m. So it will be recorded as Saturday morning 9 a.m. your application, this particular service went down. So things like this are the time series data. Another example, like your CPU utilization. So you have a CPU which is utilized up to maybe a Raspberry Pi, which is utilized to around 80%, and at that particular point of time, so that particular entry will be logged in as a time series data. So that particular data is actually the time series data. And so some of the other time series data examples that are mentioned over here is temperature data. Each day at respective times, you have the fluctuations in the temperature, and you can see the graph, a nice graph of your weather reports. Then this everybody would have seen in the stock market, all the charts by days, months, years. Same goes for your cluster. So this is what we'll be focusing today on. So you'll be having a Kubernetes cluster, all its metrics, how you can visualize that metrics, why that visualization is important, and what all fields would be critical. So those sort of data, okay, let me put it this way. Suppose you have a Kubernetes cluster. So you need not specifically know that what is Kubernetes on the whole, but just say you have a Kubernetes cluster and you are monitoring all the events that are happening inside the cluster. So all the events, the deployment that are happening, scaling up 3 to 4, 4 to 5, 5 to 1, those are getting logged, and that particular data is called time series data. This ECG report is also a time series stuff. Also, yeah, there are other stuffs that also include in the time series. One is suppose you have a log files. Now, you can have a log file that might not be getting generated every 30 minutes, but that's only once a day that a log file is getting generated. Still, that would be considered as time series data because that have a time associated with that. So it also shows that time series data can be classified into two metrics. One is the regular one, so the events that are happening on regular intervals, like on every 5-minute interval, the temperature is changing, or maybe a 10-minute interval. And regular intervals, you are capturing some sort of metrics at different sort of intervals, not the regular ones. So this is what time series data is. Now, obviously, to store time series data, the databases are already there, but time series data has become so much popular and so much important for today's real world applications that you specifically need time series databases to handle that particular set of data, to query on that particular set of data, which is huge, and to do analysis on that particular set of data. So for that, we have something which is time series databases, which is abbreviated as TSDBs. So TSDB is a database optimized for time series data, and we already know now what actually is time series data. So it can be server metrics, application performance monitoring, network data, sensor data, events, clicks, trades, and many other types. Now the question in mind, like, why time series data now? Actually, time series data is not new. You already have seen the financial stuff. So the financial stuff has already been there. There are a lot of applications that have already been using the time series data for their analytics. And because of that analysis, we have able to develop these specific set of tools, and where we are today. So at the moment, if you talk about, then finance related application only remains a subset of all the applications that are time series oriented right now. You know that take example of Tesla, it is emitting X number of datas every second to capture what all objects are there, right, left, up, down. So all those stuff will be considered as time series applications now. And most importantly, if we talk about the sensor world, so everything in this universe is having sensors now. And talk about Raspberry Pis at your for your home lab, or you talk about your generator out there in a factory, which are in thousands of numbers, and you put sensors on them to just to track what is actually the usage, when all you need the maintenance activity on that. So all those data, all those stuff, you will be able to know and capture the details, the anomalies detection, when you are capturing that set of data and storing it and analyzing it. So that's also one of the very big real world application. Then yeah, there is you can say there was one particular stuff. Yeah, this kind of workloads are difficult to optimize with the distributed key value pair. So the first question that comes in mind of the folks, like, why we already have some of the relational previous old databases, why we can't use that. So when you go over a range of data points and the percentile increases, the metrics, the measurements increases over the last 6 months, and or summarized by monthly reports, so those kind of aggregations become very difficult to optimize in a distributed key value store. And TSDBs are specially optimized for giving these multi-second level query times. Another example is, it is common to keep high precision data in short period of time. So means downsampling, the retention policies, so all those stuffs constitute the TSDBs. Now, another question that might pop up in your mind, obviously there might be more, but some of the common that I usually get, like, there are tons of time series database now. Now, which one to choose? And you also try to compare some of the DBs, like, I already have Prometheus running, why should I use Influx? I have time scale, why should I use Influx? All those things are already there. So there is one website which is DB Engines. It actually has ranking of complete RDBMS, and I specifically chose time series database option, and these are the April 2020 rankings, and InfluxDB is at number 1. and you can see Prometheus over here, timescale over here, and all the other ones. And there are specific benchmarking documents that Influx already have. Probably Michael can share all those links with you, that compares time series with the specific set of DBs, which are very relatable. But just to give you a glance, like why time series Influx is as a time series database unique for uh, managing time series data. So the set of integrations that it have, and we'll be talking more about the tick stack. Now tick stack is called Telegraph, Influx, capacitor, sorry, chronograph and capacitor. So that is the complete tick stack by InfluxData, and all four components are separate. All four components are open source. So we'll be talking about this stuff today. What I want to say over here is InfluxData was built specifically. Obviously, this had to be built for time series. Now it has all these integrations of Telegraph, Influx. I mean, all the stack, and the major difference you will see is written in this particular line. So the data model of Influx is quite different from all the other because Influx has a line protocol for sending time series data. And there is something called tag set. So the number of tags that Influx has, there is no limit, while the others have a limit of 5 to 6. The key value pairs can be in the form of int, float, bool, or string that you can store. But for the other, you have only, I think, only int is there. It is mentioned somewhere here. And yeah, they only support float values. So most of the other time series databases only support the float values. And even the OpenTS, TB, and these, which are they support tags, but they have limit which is around 5 to 6 tags. But Influx do not have the limitation because the design, the initial design is like that, which is specifically for time series. So go ahead and read these two articles. It will give you much more detail. I have just skimmed the most important points that I felt which are required to get started with this particular meetup. So now coming back to my slides. Slides will be still remain less only, but yeah. So now this particular session, we'll be talking about two stuffs. One is running Influx 2.0 as Docker container. Another one is monitoring your Kubernetes cluster. So Kubernetes, if anybody doesn't know, just in one liner, I would say it is an orchestration engine for your containerization application. So you have your application, you have broken down your application into microservices. All those microservices are running as containers, and all those containers are managed by an orchestration engine, which is called Kubernetes. Now you know like how your big applications are getting orchestrated using Kubernetes. So definitely some kind of monitoring is actually required for that huge system that we built for enterprises. So as and when your whole Kubernetes cluster or some part of the cluster, like one or two nodes, get down, so those downtimes should be captured. Now when you capture those downtimes, store it as a time series database, make a neat graph of that in Grafana dashboard or Chronograph. You will be seeing the trend. So if your trend is on the lower side, like you have very less number of downtimes, it is tending towards zero, means your platform is reliable. So that the business usually will look at this sort of metrics, like what is the trend, what is the stability of the platform. Again comes the performance. So how many of your application or the microservices went out of memory and they consumed more set of CPUs, and what is the actual network IO that is happening when the user is interacting with your application. So those performance metric charts also, if you have in Grafana, then on the whole you will be able to see, okay, this is the performance of this particular application or microservice, to be specific, so over a period of time. Then events. So Kubernetes itself, it emits n number of events, and those events are actually very essential and very critical in order to capture anomaly, or in order to detect a bug, because Kubernetes also might be having some of the bugs. So these events and all these metrics over the time, you will be able to actually capture a specific bug if it is happening again and again. All those stuff you can do. Learn, observe, predict. So you can actually process your data, process your time series data, do analysis on your time series data in Influx, and you can write Flux queries and all that stuff to predict the failures, the actual failures that might happen in future based on whatever data that you are having. Just a moment. So Kubernetes itself emits a lot of metrics. This metrics is in Prometheus format. So this is, as you can see the arrow over here. So it is cube state metrics, node metrics, endpoint exporters, Kubernetes components. So all these metrics are already there, which Prometheus pull from Kubernetes node and the API server. So these actually are the major components of Kubernetes, which emits lots and lots of metrics. Now comes our tech stack. Telegraph will take all these metrics and push to InfluxDB. Now, InfluxDB, you can prepare your dashboards and use Grafana, and same you can use for your alerting. Now, I'll be showing you the criticality, why Telegraph is important, what actually Telegraph is, and how Telegraph is helping to become one-stop solution for having all sort of metrics at one place. And then Influx is proving to be a one-stop solution for storing all sorts of data. So next, this is a typical tech stack architecture. So like I said, I'll be spending less time on theory and more time on the demo. But this is actually important, and this is exactly the same from previous diagram. So you can see the Telegraph agent, this particular thing. Telegraph agent is taking metrics. Now one metrics is K8 stats, which is the Kubernetes one. Next metrics is networking metrics. So when you are monitoring a full-blown Kubernetes cluster, you don't only need the specific K8 metrics, you need hundreds of other metrics as well, because your applications is not spread across only a small Kubernetes cluster, or even if it is, then your only Kubernetes metrics won't help you that much in analyzing the depths of the anomalies that are happening with your system. You need to monitor the actual VMs, you need to monitor the databases where your data is going, you need to monitor the network calls, the system traces. So all the networking messages queues have to be monitored, and here Telegraph proves to be a one-stop solution where all these metrics can be scraped and sent to InfluxDB. Now InfluxDB, like we have already discussed, it's a time series database for all this data. Now Cronograph, as you can see above, it's an interface for InfluxDB platform. So you can write the queries, you can create your dashboards over here. We'll see that in the demo itself. And capacitor is something which is really cool. It is a real-time streaming data processing engine. So all the prediction thing that I was talking about, you can do here. You can have anomaly detection, machine learning, user-defined function, and then alert based on that on the alerting frameworks. And that's a typical architecture of Influx on the whole, with all the components. Basically, it's called tick stack. So you can call it TICK, but I prefer to call it a tick stack. So let me go to the next slide. Yeah, this one is not important. If we have time, I'll cover this particular portion. But for today's, we have covered what is time series. What I'll do is I'll keep on posting these links in the chat quickly, or maybe I'll hand it over to Michael later, and then we can do. So just before jumping into the demo, so there are two Influx versions going on in parallel. One is Influx 1.x and another one is called Influx 2.x. Now Influx 1.x is a standalone InfluxDB wherein the Telegraph, Cronograph and the capacitor components are different. And obviously Influx 2 will have a lot more features, but the major difference is Influx 1 has InfluxDB standalone. Now the Telegraph components, if you want to integrate, you have to integrate separately. Same for the Cronograph and same for the capacitor. But when you go to Influx 2.0, and by the way, Influx 1.a recently got released, 1.8, and these are some of the key features, the release notes. And if you go to Influx 2.0, which is right now in beta 10 or beta 9. I'm not sure the exact which beta version it is now. So it is an integrated system with all the tech stack components. So if you run Influx 2.0, you will be running actually a whole set of Telegraph, Chronograph, capacitor, and Influx as a single piece. So everything now comes integrated with much more features. The Flux is natively supported. So Flux is another query language. If you want to see, you can go here. The Flux language documentation is there. Flux is a query language, so for powerful queries. I can show you the example in the demo. Capacitor documentation is also there. Flux versus InfluxQL. So they are, I mean, in the end, people will start using Flux as per my opinion, and it will be the single go for all the query processing. Then DB engines is already done. Let's go to the demo part now. So this is a guest that I have prepared, and exactly these set of these small commands are there that you need to just paste and run. So this particular is important to give everybody in the chat. I'll just give to everyone. Yeah, so you have the guest, it's a public guest, and or gist. So let's go to demo 1. So this is a playground which is called Katacoda. It's free and you don't have to do anything for that. Just click on the first link and the Katacoda cluster will be there. I would suggest first listen and then probably try to do it rather in parallel, because maybe some sort of things could miss. So there is a GitHub repository that we need to clone first, and we'll go through the components of GitHub repository. Oops. Yeah. Let's cd into that repository, then the Kubernetes folder, ls. So it have a few of the folders. Maybe the good thing would be to actually open the GitHub repository and just walk you through some of the components. You may not be an expert, but I just want to show you one thing, how easy it is to scrape metrics via Telegraph and send to Influx with just a few lines. That's it. That's actually the beauty of Telegraph. So this is the Influx setup. So if you go to Influx setup, you will be seeing that it is just pulling a 2.0 alpha image. So maybe it needs to be updated. So it's running 2.0 alpha image, and this is the YAML configuration file, which have the deployment and the service. Now the major portion is you can go to any of the maybe node, and here you can see Telegraph and Telegraph config file. Now Telegraph YAML, it is running as a daemon set. What a daemon set means, all the nodes within your cluster, this particular pod will be running. That simply it means. So, but the major portion is the Telegraph config file. Now, in order to send the data that we were talking about in the PPT, like you can send networking data, you can send this data, you can send that data. How you can send that data? By just giving input fields. So you can see inputs. So I want to capture all my data from within Kubernetes cluster. What I do is I just give inputs Kubernetes, the URL, the API URL, the token if it is there, and some of the other fields. But this is on the bare minimum that is needed. That's all, and all your Kubernetes data will start flowing to the output, which is the Influx that we have configured over here. I'll show you when this will be running, then we can go, because it will take some time. So there is a make file. You just do a make command and let it set up. In the meanwhile that it is setting up, we'll go to Telegraph input plugins. So there is a GitHub repository. Obviously, it is open source, and all the code and the data and stuff, the plugins, it is already there on Telegraph. So we'll go to the input plugins, and you will be amazed to see the number of input plugins that Telegraph has. And these input plugins are actually the sources of data from where Telegraph can scrape the metrics. Now just keep scrolling and you can see the number of input plugins that Telegraph is having. Isn't that incredible? Just from Telegraph, running Telegraph as a daemon set or maybe as a single deployment, and in the configuration, whatever you need, whatever comes up in the future, you just already have a plugin or somebody is actually building it. You have Stackdriver, you have Docker. So you can see in the Docker, the plugin is there, and you can see how easy it is to configure it. This is required, this is required, and some of these things you can have your timeouts as well. Now, these are some of the optional TLS settings that obviously it depends on the enterprise level of your application. If you're testing, then it doesn't matter. So you can see how easily this particular thing you can copy paste, put it in your Influx, in your Telegraph config file or in a config map when you are deploying it as a Kubernetes solution. So your Docker metrics will get starting scraped. And these ones are actually very easy. Input CPU, that's it. Inputs memory, that's it. You don't have to do anything. Or network, I think, was there somewhere. Kernel is there. So just see the amount of lines that you actually have to write to get the metric scraped via Telegraph and send it to Influx. So that's the beauty of Telegraph, and that sort of integration that is here. Now, Telegraph not only have input plugins, it also have output plugins, and there are tons of output plugins. You can check that. But here, let's discuss now Influx on the whole. So since this is Influx 2.0, the biggest advantage that you get is everything is integrated. And when I show you the beta one, you will see how easy it is to configure Telegraph as well. So once your this completes, it says that your deployment is completed. CLEAR. Okay, now we'll do a kubectl get svc. I think it's in monitoring namespace, but anyways, we can grab that. So it is running on 30823. Now from Katakoda cluster, how you open a service is open a new port like this, and instead of 8080, you post your the node port that you copied just from there, and your Influx is there. It will ask for a username password, so it is in the repository itself. You can clone it, you can change it. This repository was created initially by David. Forgot it or no? No. Okay, cool. So that's how it doesn't look like this now. It is much more enriched UI, but that's how typical InfluxDB looks like. You have your a data explorer section, you have your dashboard section, you have your task section, you have your monitoring and alerting section, you have your load data section, and you have the settings that you can do. So for this particular demo, let's go to dashboard. So now there are already pre-created dashboard that you can create from templates. So what we'll do is we'll create a Kubernetes dashboard, and it will capture all these stuff, and we'll create dashboard. And in the meanwhile, when the dashboard is created, we'll run some of the some workload over there. And let's run. And maybe 10 replicas of that. So in some time it will be created and done. So your dashboard is created, and when you click on the dashboard, it will start capturing and loading the data. It might take initial few seconds to load the data, and after that it will showing the numbers over here. So once it shows the numbers, in the meanwhile, what we can do is, have we covered the first gist? You have done. So you can see that there are 10 containers that are getting created. After that, your pods will be in running state. Once your pod comes in running state, you will see the data over here. You can see what all things are actually, what all nodes are actually there, their capacity, and below you can see what all the containers. I just spinned up Nginx with 10 pods. You can see the container names, the namespace, the pod names, and the status. They are still in the container creating state. So we can actually do a 5-second refresh for that. You can do this. You can create a pre-created dashboards from here, and you can explore your metrics from the data explorer. You have all these things that are already getting scraped. You have Kubernetes node, Kubernetes deployment, Kubernetes pod container. Go there and I'll just click one. Go there and then you can select your CPU usage nano cores, and then maybe all the container names, specific ones. So it will give you your CPU usage nano cores. Now, why this is important, why I'm telling you this specific metrics is this is also a kind of use case. Like your application, or maybe you have a platform where people are running the application in Kubernetes. So you want to have dashboards where things are like, what is my actual CPU utilization when I am running the pods? What is my actually memory consumption when I'm running the pods? So those sort of metrics are actually very important. It helps you to tweak the capacity that you want to allocate for that particular pod. So things like this are very important. Then obviously there are other tons of metrics that you can explore. So this particular screen that you are seeing is called Cronograph. Like I told you, Influx 2.0 comes with integrated Cronograph, so you don't have to install a Cronograph separately. So Influx already have that particular built-in module for built-in component of Cronograph. So this finishes our first demo. Now, in the second demo, what we'll be doing is I'll open one terminal. We'll go back here. What we'll do is if you go back to Influx 2.0, start with Influx open source. I clicked on cloud. Start with Influx open source. You can see that there are tons of options that you can install on Mac, Linux, Docker, Kubernetes. So we'll be using simple Docker command to run Influx 2.0.0 beta. So now I'll copy. I already put that in the gist. I'll copy. Yep. And on the second instance, I will just configure Telegraph, because Telegraph will not configure, we'll just install Telegraph. The configurations will be done via your Influx 2.0. Copy all these. Paste. So it is running. Let's see a Docker container. Okay, it is downloading the image. Yeah, so your image, your Influx has started. So again, do the same thing, open another port, and this time Influx will be running on 9999. Press enter. And you can see the latest and the greatest version of Influx. We'll see, get started, give username, maybe Influx Meetup, and just random password, test organization, test bucket. We'll continue with that. Now we already know the we are the advanced users, so let's click on the advanced stuff, because I want to show you something really cool. Here you can see you have buckets, telegraphs, scrapers, tokens, and the client libraries. What I'm interested in, so you actually can use the Go client, Java client, Python client for having a Python code which is sending data to Influx. You can send data from Excel and parse them, and you can send data from a JSON, parse them, convert it into Influx format, and send it. But the major thing that we are interested in Telegraph, why we are interested in Telegraph, is because already Telegraph is so easy, but I still don't want to create a configuration on my own. So Influx 2.0 provides you with the capability of creating the configuration here from the UI directly. Now we have already done for Kubernetes. Let's do it for system just to see another sort of stuff. So we click on continue. So on the left side you can see what all plugins. So the input plugins that I showed you earlier. So what all plugins will be enabled if I create this particular Telegraph configuration. So system, processes, net memory, disk IO, disk CPU. So let's name this system and create and verify. Now what happens is it generates a token and it generates a config file that we need to apply using Telegraph. That was the reason why I installed Telegraph at first place. Let's open a new terminal over here and export the token first, and then where it went? Okay, yeah, let's do the Telegraph config file and we press enter. And now when we click finish, you can see on the right side, it will appear it has created a dashboard. Okay, the notification already went. So it just notifies you that your Telegraph is created and your dashboard is also created. So by default, it creates a system dashboard also for you. You see, right? I never went to the screen and I never created the system dashboard from my template, but it is already created. Now when I go into the system, you will be seeing that I already have the metrics available. Isn't that cool that, you know, within few minutes, we have just set up Influx and we have already created a Telegraph configuration file, deployed it to capture and monitor your node metrics. We already have Kubernetes metrics. So what we did, we just ran a small gist, which is really, so that, you know, that defines how easy it is actually to use InfluxDB. And there are some more cool features on InfluxDB, which is called retention policies and downsampling. So like pod emits thousands of metrics, but you want only the maximum CPU utilization that for a particular pod, or maybe a maximum CPU utilization for a node to be get stored for a longer duration of time. So what you can do is you can create a retention policy on a measurement for longer retention of specific metrics. Now the aggregation can also be done on Telegraph level. You can actually select what all metrics you want to send from Telegraph using the aggregators over there itself. Next level aggregation happens in Influx. You can create retention policies and store only specific set of data for longer duration. How that aggregation happens is using continuous queries. So we use continuous queries to create specific retention. Okay, while I'm speaking, you can continuous queries and Flux. You can actually see the documentation, like what actually the continuous queries are. So there are a lot of blogs also, so by the community. So you can create a continuous query on the database system, and you can have specific set of data grouped by time. You can use all the clauses and send only that specific one record out of 1,000 records and capture it for 1 year, 2 year, 3 years with multiple retention policies. So that sort of downsampling, retention policies, and sharding, the TSI indexing, that all you can do with Influx natively. Now you have a full capacitor support with your Influx 2.0. And if I click on, I'll show you one of the boards. It is already here, right? So if I click on maybe settings and configure, so this is the language. This is how the you know, metrics is getting captured. I mean, metrics is getting displayed for this particular stuff. So you can write your own stuff. It is not that difficult. It is easy. You can download it at CSV. This was a very big requirement which most of the UIs don't give you, like downloading as a CSV, or, you know, sending alerts. You can have monitoring and alerting on top of all your metrics that you are doing, and you can create a threshold check, notifications, notification rules. So all these things you can do via Influx. And you have different scrapers that you can you can create as scrapers from the UI. So, you know, the good part is, even you need not be a system administrator or a database administrator to perform all these tasks. You can be a developer, you can use one of the client libraries and send the data, because sending the data and seeing the data and installing that is not a big task. So since this is kept on a very close level of a very easy level of installation part, so even a developer can easily install and manage a fully enterprise grade influx for that. And maybe Michael can tell you, or you can see there are influx open source. Then if you want support or high availability, full high availability, you have influx enterprise, which is obviously paid. You also have influx for cloud, which is there on Google Cloud as well. So you can go to Google Marketplace, and you can have influx installed for that as well. So all those things are also there. The last thing that I would conclude with in today's demo is the influx HA architecture from the open source version that you are having. The slides will be shared to you, so you can use this particular architecture for having influx open source with a high available solution, which by default it will not be there, but obviously you can do some stuff with, you can play around with relay. So relay is another another project under InfluxData itself, which have been created for this specific purpose. So you use the relays for syncing the data between different influx, and that's how you make it HA in any other cloud. And this was a sample Telegraph file. This is a config file of the Telegraph agent itself, like what are the outputs, and these are the inputs. Kubernetes, CPU system, we have seen all these things. So yeah, I wanted to cover everything, so I might have gone a bit fast, and but since these demos are readily available, you can do them and it'll work 100%. So you just do it, test it out, see how it works, and use Telegraph, the power of Telegraph plugins to scrape metrics from different sources, send them to Influx, do certain queries, do the joins using Flux, do all that stuff, and just post out on Twitter and shout out like what all you did. I would love to see your different use cases. So that's it from my side. I'll put the thank you slide. I have it. Okay, good.
Awesome. Would you be okay, Saiyam, with us stopping your screen share, and I'll go ahead and take over?
Yeah, I'll do that right away.
Awesome.
Cool. And I hope everybody liked the session.
So now we're going to move to the Q&A portion. It looks like we've had several questions that have come in during the course of your presentation, Saiyam. As a reminder, if you have any questions you'd like to ask, you can use the Q&A feature in Zoom to go ahead and ask those now. First question is, what is the difference between a time series database like InfluxDB and a MySQL or PostgreSQL? Can't MySQL handle this type of data?
Okay, so I already, I think, answered some portion of it when I was discussing like why time series is actually important, and why the traditional normal databases would not be able to do is because there are so many stuff. You can do it, but the level of complexity involved in doing that, it will be high. And also you can't do it on that scale. So you can't do it for a 2-year aggregation on daily basis, or you cannot have your all these components, that the integrations that I'm talking about, the whole tech stack integrations, the 200 plugins data. Can you imagine you write everything for MySQL and having scraping data from 200 different sources? So all those stuff would be here different. Slides will be shared. We have been using OpenShift environment. Yeah, go ahead, Michael. You can tell me the questions.
Great. Rob asks, will you be sharing your slides at the end of the presentation?
Right. I'll be sharing with you.
Great.
Everything I have discussed is open source, and there is no harm in sharing open source anywhere.
And also, if you'd like to check anything out, you can view the recording. We'll be posting that to YouTube, hopefully later today. We still need to download it, do a little bit of editing on the front and tail end, and then we'll be posting it up to our YouTube channel for later viewing. So thanks for asking that question, Rob. The next one's not quite a question. We have been using OpenShift environment and using Prometheus, I believe that's as a data source, and Grafana for visualization. Do you have any thoughts on that setup?
OpenShift plugin, I'm not sure whether OpenShift plugins is already there. So you have to go through the repository, and maybe you can select certain number of plugins, and obviously Prometheus. The main thing is Prometheus Influx natively supports Prometheus scraping. So what you can do is you don't have to touch your existing architecture. So, but Prometheus doesn't support HA by default and long retention. So that is the biggest problem in Prometheus at the moment. So longer retention periods, all those stuff is very difficult using Prometheus. Grafana still use the same. You can scrape direct metrics from Prometheus, and in the same Telegraph, you can have additional sort of metrics that you weren't able to do before using with Prometheus. So you can have Prometheus plus additional set of input plugins, send them to Influx, and do whatever you want to do.
Awesome. Ioannis from Greece asks, is that repository you spoke about public? You seem to not be able to find it in your GitHub.
That repository is public. I think in the guest only itself, you should be able to find that. I'm not sure why you are not able to do that, but yeah, it is public, and it's in David's who works at InfluxData itself. That there also the repository is public. So that's the demo that Influx has built is what I've shown with some optimizations.
Our next question is, Saiyam had mentioned you also have Telegraph work as a pull mechanism from Prometheus. What is the benefit of using Telegraph and sending it again to Influx when I'm using Prometheus as a data source?
Again, I would answer the same thing. Telegraph has 200 plugins, and you can't have everything captured using Prometheus. You can use Prometheus as a Telegraph input plugin plus 100 of other data scrapers that can get you the data from other additional sources, which is actually required. Believe me, you will never work in an enterprise that just says, give me the cluster data and I don't need anything else. Every now and then, or every quarter or every month, you will get a requirement of adding additional resource which you want to monitor. So you can't write scripts and all that every time. Just use a simple plugin which is already there or being developed. Over 200 very important plugins are already being developed, and that's a very massive repository, and it is checked in every day on daily basis. New plugins are getting developed and people are using it.
Great. I think that answers both of our next questions. Mirzadi also asks, why is Grafana plus Telegraph plus Prometheus better than Grafana plus Prometheus?
Grafana plus Telegraph, again, same. So Telegraph will help you capture a number of metrics from different sources of data.
Great. Thank you both for asking those questions. Ioannis also asks, what is Katacoda?
Katacoda is just a playground it's a free playground that you can use for different sources, different scenarios to learn. So it has a scenario based learning approach where you can learn Kubernetes, Docker, CNCF stuff, Ubuntu. So you go ahead, katacoda.com, sign up, free account, and you can do whatever you want. That's why I chose Katacoda over here, so that you can actually go back, test it out without having your own environments.
That's great. And a follow-up question. What happens if I create a retention policy and apply it on existing data in Influx 1.7?
Yeah, so if you apply on the existing data, so the next set of data that goes after creation of retention policy will be stayed for that particular duration. And Influx 1.7 happily supports retention policies.
Great. Our next question is, we are using TickStack in my company, but I'm not understanding how to visualize data on Cronograph, having trouble to understand units on the y-axis.
Okay, so maybe the thing is the exact same query that you might be running in Grafana that might not run as a copy paste because you need to have your DB name, retention policy, then dot the measurement name. So all those things you have to properly define that, and also you have to take care of the fields and tags. So it's not every time you can select a tag from this measurement. So you have to select a field from measurement and group by the tag. That's how, maybe that's why some problem might be appearing. But still, if you have any detailed discussion, you can probably post in the Slack, and we can Michael, you can share your Influx Slack channel and we can help over there.
Absolutely. And we'll share that link here in just a moment, so that way anyone can join the community Slack if they're interested.
Yeah.
Can you share some differences between some HA and centralized multi-cluster monitoring feature like Fauna for Prometheus and Influx?
Yeah. So, like I said, you can use relay for the HA architecture. So, relay's responsibility is to sync data between Influx, both the Influx instances, or you can have a number of Influx instances depending on your need. So, even if one Influx goes down, the other comes up. The another architecture that is there is you can have your Kafka queue. Just keep on sending data to Kafka queue, and that Kafka will be syncing to Influx. And if your Influx goes down, you can have a buffer size also for this particular data, wherein you can keep a buffer in Telegraph itself if your Influx goes down. So all those things can constitute different parts of HA architecture. And as far as Thanos is concerned, so yeah, you can use Thanos, but still you won't be able to the ease of deployment of Telegraph, the whole tech stack, and now it is Influx 2.0. You actually don't need to deploy anything else. Earlier, we used to deploy the components separately. Now you only have to deploy a single piece of component, and everything is there and there itself. And natively, since it have Prometheus support, so I would say definitely use it.
Great. Sangam asks, seems to be having a little bit of trouble with memory. He says, why is InfluxData taking up so much memory on my machine? How do I overcome memory usage challenges?
That's a great question, Sangam. So memory consumption. I wrote an article on that. Let me find that. Memory consumption Influx. So the thing is, Influx is a memory hungry operation. The more memory you give it, it tries to consume all of it. Why? Because it wants to give you the result as quickly as possible. So the more memory you give, the more it takes. So if you are running it as a Docker container, I actually faced that issue. So there are two types of indexing. One is called the TSM indexing and another one is called the TSI indexing. So I'll quickly post the link in the chat. So how to overcome the memory usage with time series index. So it is very good read, and here also I explain how actually you can set up and you can migrate from TSM to TSI index even for existing. So someone asked, I already have Influx running. So you also, if you are facing memory issues, definitely go through this article. Flawlessly it will work, and you will have a big performance improvement and less memory impaction. And another tip, if you're running it as Docker container, you can give the memory as maybe 80% and reserve 20% for your system so that your node doesn't go down.
Awesome. Excellent question, Sangam. And I think you asked the perfect person that question. Saiyam wrote that article and I've taken a look at it. It's really a nice read. So be sure to take a look and hopefully that'll be able to address your questions. Our next question is, we receive vibration data from sensors at a very high rate, around 20 GB per hour, or around 20 million records in an hour, which becomes around 500 gigabytes a day. Currently, we are using timescale, but at times it gives up loading this much data. Do you have any estimates about how InfluxDB, that at max, how much data can be shoved in per hour?
Aman, so Aman, the thing is, I would suggest there are some of the benchmarking documents that Influx has done already. So probably those benchmarks would give you the exact numbers. But as far as I know, the more core you will give, as I said, the more memory you will give it to Influx, the more faster results on the read operations you will get. But I'm sure that I have compared it to not to time scale specifically, but to other DBs. The comparison of the performance of retrieving a rate of Influx is pretty high. So, but the exact numbers I'm not sure. Maybe the benchmarking articles will help you out. Let me see if I can find right away. But if not, I'll give you the other time, or maybe Michael can help in that.
Absolutely.
Benchmark.
You could also follow up on the community Slack, and we can have more discussion about sharing some white papers, benchmarking articles, and things of that nature. Great. And Saiyam, if you do find that article, go ahead and post it into chat. Thank you, Marzadi has to step away. Thank you for joining us. Can you add something on the alerting feature and integration with some PagerDuty services using some capacitor and other components?
Yes, you can do that. With capacitor, you can have all the alerting mechanism you can configure over there.
Suresh writes, you mentioned that the latest version of Influx will have all components of the tech stack included under one roof. How performant will it be when compared to the previous architecture and when we have all applications running on one node or instance?
The thing is, architecture still remains the same because it's just that now it's a single binary. Earlier also, if you run Telegraph, you have to run it on the same node where Telegraph has to be running everywhere actually, and you can have Influx as separate. But the thing is, the integration, I don't think it caused any performance impact for me. I have been using it, so there's no performance hit as far as I have seen.
Great. And last question, Ernesto asks, can you get data from an OPC client that gets tags from a control system using Telegraph and send it to InfluxDB?
I am not sure about that. We need to check the Telegraph input plugins and see how it can be done. If not via Telegraph plugins, then we have to use one of the source codes like the clients, like the Go client or Python client or Java client to write a code to scrape that matrix and send to that. If the Telegraph
actually, I can answer that. This is Chris from
okay.
InfluxData. So there's actually a number of tools out there that are open source that write from OPC UA directly into InfluxDB. So we can definitely send you the link. It's also on our website where those are. And then we are also working currently on a Telegraph OPC UA plugin as well. So that'll come soon. But the current solutions that are out there work perfectly.
Great.
Awesome.
Thank you, Chris. Thank you, Ernesto, for asking the question. If you have any more questions, we can go ahead and follow up via community Slack. And we'll go ahead and since we're running a little bit short on time, we'll move quickly through our announcements. First announcement is we want everybody to stay involved in the Time Series community during everything that's going on. I know if you're like me, you're probably getting bored with staying home, staying in, and doing the same couple of things every day. So we hope that everyone tuning in can stay a part of the community during these uncertain times. I know a lot of us are stuck inside, feeling a little bit bored. I like to work on projects personally, some fun side projects, little fun things just to keep myself busy. If you're like me and you like to do that and you're working on something interesting and you'd like to share it with the community, we would love to hear from you. Reach out to us via email or at Slack, and we'd love to hear what you're working on and see if you'd like to present it at a virtual meetup or write a blog article about it. We'd love to hear what you're up to. Even if you're not interested in presenting or writing an article, we're still interested in hearing from you and knowing what you've been up to. So I encourage you all to hop over to the InfluxDB community forum that can be found at influxdata.com/community. That's a great place to introduce yourself, poke around, ask questions, find help, learn solutions, share ideas, and follow along in the discussions. As we mentioned just a few minutes ago, we also have that Slack workspace that is open to our community. That can be accessed via influxdata.com/Slack. That's another great place to meet other community members, share your knowledge, and get help from other people in the community, as well as InfluxData staff. Even if you don't have a support issue or a technical question, we do encourage you to come by the Slack, join the community channel, introduce yourself, even if it's just to socialize with other members of the community. And if you're a Redditor, we also have an InfluxDB subreddit available for you. So a simple search should pull that up in case you want to pop over and check that out. Also, a cool announcement. Today, we officially launched InfluxData templates. Templates were made to provide a way for you to share configurations with other users and work together to enhance and improve those configurations over time, just like you would with any open source project. It's a logical feature since many of our users have the same or similar use cases. So if you're interested in learning more about templates that launch today, you can pop over to influxdata.com/community and click on the templates link. That's a great place where you can share, learn about templates, publish your own, and see what other InfluxDB users have built and give those a try. So we encourage you to pop over and give that a look. Another quick announcement is that the upcoming Influx Days conference has been moved to a virtual event. It will now take place June 23rd and 24th. This edition of Influx Days is pretty cool because not only is it the first time we're doing a virtual event, but it's the first time we'll be holding it at zero cost for all attendees. So if you're interested in checking out Influx Days and seeing what that's all about, now is the best time to do that. We hope you're able to join us. We're going to have lots of great talks and presentations about all things time series. Also, we will still be offering our 2-day professional Flux training session, but now that'll be as a live remote education event. Space for the hands-on Flux training is limited to 50 participants. The Flux training is a paid activity, but in order to help out the community, we have decided to reduce the cost of that Flux training by 50%. So now it's 250 GBP, if I'm not mistaken, British pounds. And if you're interested in presenting at an upcoming Influx Day, the schedule is set for Influx Days virtual, but San Francisco instance of Influx Days is still currently planned to take place in person, October 20th and 22nd. Hopefully by then the world would have gone back to some sort of normal. And we are still looking for great presenters for Influx Days San Francisco. So if you're interested in presenting, please hop over to influxdays.com to learn more. And there's a link there where you can submit your CFP. So we've had a few different people submit links to job postings that they have available. Something that we normally love to do during all of our meetups is share open positions and job opportunities at our respective companies. Do go ahead and use the chat feature now if you have a job position that you'd like to share, or if your company is hiring. I'm sure a lot of people would be interested in that. Please let us know the name of your company, the types of roles, and whether or not the position is remote friendly. Here at InfluxData, we are currently looking to fill software engineering e-commerce roles based out of New York and San Francisco, but we are a remote friendly company. We're also looking for a full stack developer to work with us, to work with our San Francisco team. So we encourage all qualified applicants to take a look at our job board and apply if you're interested. Also, I want to thank Maxime for sharing those open positions in the chat channel, which was Causalens.com, excuse me. It took me a moment to parse that out. So check out Causalens.com. They're hiring a number of positions. And I'm just going to quickly check the chat. Okay, great. So for a raffle, we're running a little bit short on time, so we were going to do some fun riddles. But I think what we'll do for a raffle is take it offline. We'll download the attendee report, and for anyone that's present for the majority of the call, because we want everyone that was able to join today to have the same chance of winning one of our prizes. So what we have today is 3 hoodies. We have 4 t-shirts and 5 pairs of socks. And so what we'll do is we'll do a random number generation to identify the people that we'll be reaching out to via email. And then once we get your shipping information, we'll send that out to all of our winners of the raffles and the swag items. So thank you all so much for joining. Thank you for staying 10 minutes late. We hope you can tune in live for the next virtual meetup, which is taking place on May 28th. If you're interested in finding out more information, you can hop over to influxdata.com/community to learn more. Follow the link to the Time Series Meetups and register to join. Thank you so much